What if the light detected in space wasn't natural? This isn't a glitch, this isn't a reflection, and it definitely wasn't expected. In 2024, astronomers tracking an object called 3I Atlas noticed something impossible, a light source, not just any light, but one that appeared activated. At first, scientists tried to explain it away, instrument error, cosmic reflection, but the data didn't match. The light was consistent, controlled, and it came from a place where no light should exist. That's when the situation changed. Because this time, the CIA was alerted. Why would an intelligence agency care about a distant object in space? Why were certain reports quietly reclassified? And why did experts suddenly stop answering questions? What if this wasn't a natural phenomenon at all? What if 3I's Atlas isn't just passing through space, but doing something? Tonight we're breaking down the evidence, the data that raised alarms, and the theory no one wants to talk about. Watch until the end. Because if this light is artificial, then we are not just observing the universe anymore. Something may be observing us back. On the morning of January 7th, something happened that none of our models predicted. A point of light deep in the black fabric of space intensified, not gradually, not erratically, but with startling sharpness. It lasted no more than 6 seconds, and in that short burst, the object known as 3I Atlas changed how we understand interstellar visitors. This wasn't a comet shedding material under solar heat. It wasn't a flare from magnetic turbulence. This was not passive behavior. It was active. Deliberate in shape, structured in duration, and it began with light. At exactly 3:21 UTC, photometric sensors stationed across 5 continents registered the same anomaly. Observatories in Hawaii, Chile, Japan, the Canary Islands, and South Africa all recorded an identical surge in brightness from a known location in the sky. 3 Atlas at that time was on its outbound trajectory, having passed perihelion weeks earlier. It was cooling, slowing, drifting, at least according to the data. But what these observatories recorded was not a cooling object. It was an ignition. The light signature rose sharply, forming a peak within just 2 seconds, and then held steady before collapsing with equal precision. No known comet behaves this way. Outgassing produces irregular curves. Fragmentation leads to chaotic brightness swings. Even solar reflections scatter unevenly across rough icy surfaces, but this flash had order. To the naked eye, the spike would have appeared as a simple twinkle, a pinprick surge in the darkness. But under scientific scrutiny, its shape told another story. The brightness curve formed a trapezoidal waveform, not the bell-shaped curve of thermal emission. This means something didn't just brighten, it turned on, held, then turned off. Within hours, data pipelines were saturated. Timestamp logs were pulled from optical arrays, filtered by wavelength, and examined for distortion. One signature repeated in every dataset. The emission spectrum was tight, not spread like thermal radiation, not scattered like reflected sunlight. The energy concentrated in a narrow band, mostly in the visible white range with a faint secondary spike in near-ultraviolet. This precision disturbed researchers because it resembled something unnatural. At the Harvard-Smithsonian Center for Astrophysics, a team attempted to model the emission using known cometary behavior, dust scattering, gas jets, thermal flares, but each simulation failed to replicate the clean ramp-up and collapse seen in the light curve. There was no chaotic decay, no dust bloom aftermath, no extended heat glow. It was as if the object had pulsed briefly, like a calibrated machine. But light alone can mislead. So astronomers checked the surrounding space. Was it a passing satellite? A flare from a nearby body? The answer was no. Nothing else in that sky sector showed changes. The spike was singular, isolated, and fixed to 3I Atlas's coordinates. Then came the angular analysis. When plotted against the Earth-Sun line, the light emission angle was nearly exact. The beam, or whatever mechanism generated the spike, aligned within half a degree of the direct Earth-facing vector. In orbital terms, that's surgical. Comets don't aim. But this one seemed to have done exactly that. There was no aftershock, no repeat pulse, just silence. But it was a silence that unsettled everyone watching, because it meant the object had returned to baseline, as if it had completed an action, not a symptom, not an accident, an event. And so the question emerged quietly, in internal memos and encrypted Slack channels. What did we just witness? Because in the language of astrophysics, light is information, and this light didn't behave like nature's randomness. It behaved like a system, and somewhere, someone, or something, had activated it. As soon as the flash was confirmed across multiple observatories, analysts turned their attention to one question. Where did it point? Because in deep space, light doesn't just radiate, it travels. It moves with intent, with direction, and with consequence. And when the data from January 7th was reconstructed, one fact became clear. The light from 3I Atlas wasn't just emitted, it was directed. At first, this idea seemed absurd. Comets are not directional objects. They do not emit beams, structure their illumination, or focus their energy. But 3I Atlas had already violated many expectations, and now, when the emission vector was analysed in relation to the solar system's orbital layout, a strange alignment emerged. The beam, if it can even be called that, followed a path within 0.5 degrees of the Earth-Sun vector. That is, it pointed directly toward Earth, with an accuracy too precise to dismiss as coincidence. In the language of orbital mechanics, this isn't just proximity, it's intention. Here's how it was determined. Using timestamps from the 5 optical observatories, researchers plotted the peak moment of brightness against the object's projected trajectory. At that exact instant, Earth occupied a specific coordinate in heliocentric space, and when you drew a line from 3I Atlas to Earth, through the background stars, across the solar plane, that line matched the angle of light emission within a margin of error so narrow it set off alarms in more than one control room. If this were a random outburst, say, a fragment breaking off or a sudden burst of gas, its light would scatter outward in all directions. Dust and ice would reflect sunlight omnidirectionally. Even the most violent natural jets follow curved, chaotic paths shaped by spin, solar wind, and sublimation. But this wasn't curved, it was straight. ESA's trajectory reconstruction software, normally used for asteroid pathing and satellite maneuver validation, was repurposed to simulate the flash. When it traced the cone of light backward from Earth, it intersected with 3I Atlas's location at the moment of the burst. And when it simulated the cone forward, projecting where the beam would continue, it passed through nothing. No planets, no moons, just black. As if the emission wasn't designed to pass through the solar system, but to end at Earth. The geometry became even stranger when spectral overlays were introduced. By comparing the angle of light emission with the comet's tail and orbital velocity, analysts discovered a secondary alignment between the axis of rotation and the vector of the pulse. This means the object may have rotated into position before emitting, and that rotation, slow and controlled, preceded the event by just under 90 minutes. To those in the field of spacecraft telemetry, this sounded eerily familiar. That's how antennas behave. Satellites realign, probes orient before data transmission. Not randomly, not incidentally, with purpose. Naturally, skeptics pushed back. Maybe the beam was just a forward-facing vent, material ejected in a straight line. But that theory collapsed under its own weight. Jets don't emit light this way. They scatter dust, not compress photons. And the light pulse's narrowband nature didn't fit the thermal profile of outgassing. What was left was geometry. Clean, chilling geometry. Light pointed at Earth, like a lighthouse beam sweeping across an ocean. A momentary flicker, yes, but a flicker on a fixed axis, tracked across multiple independent detectors from multiple continents with one shared conclusion. Whatever 3I Atlas did on the morning of January 7th, it pointed it here. The moment the flash from 3I Atlas was triangulated and its direction confirmed, something shifted. Not in space, but on Earth. Because while astronomers pored over the physics, another kind of analyst was watching from the shadows. In the hours following the pulse, queries began appearing across encrypted space tracking platforms, not from observatories, not from universities. From US government nodes. It started with an unusual request to the Space Surveillance Network, a joint operation between the Department of Defense and civilian observatories. The request was narrow, full photometric logs of 3i Atlas for the 24-hour window surrounding the pulse. The requester, an internal branch of the Central Intelligence Agency, specifically the Directorate of Science and Technology. For those familiar with the intelligence world, this wasn't surprising. The DS&T doesn't just monitor human activity, they're tasked with understanding emerging technologies, foreign or otherwise, and when a previously quiet interstellar object emits a sudden directional pulse of light aligned with Earth's orbital plane, they take notice, quietly, but quickly. Sources within the International Data Relay Consortium, which had been observing 3i Atlas independently, reported being contacted by US liaison officers just 12 hours after the event. The tone was polite, the requests were specific, and the language was unmistakably defensive. We'd like to see the raw telemetry from frame 2371 to 2390. Do your sensors register any background RF harmonics at the moment of the pulse? Has your station recently received inbound light curves that appear modulated? They weren't looking for dust, they were looking for signal. In the days that followed, multiple observatories received informal advisories, not cease and desists, not outright censorship, but soft pressure. Hold your conclusions, wait for further confirmation, keep the raw data offline. One observatory in South America, known for sharing open-source data with amateur astronomers, quietly removed a set of frames showing a geometric flare pattern. No explanation, just gone. Researchers on that team later admitted they were contacted by individuals claiming to represent a joint international security assessment group. No names, no titles, just credentials that checked out. Barely. This wasn't the first time. The CIA has a long, quiet history of watching the skies, not for weather, but for information. During the Cold War, analysts routinely examined celestial anomalies for signs of Soviet tech tests. Later, the same teams reviewed deep space flashes that might signal clandestine satellite deployments or early warning decoys. But 3i Atlas was different. It wasn't man-made, not by us, and that's exactly why the agency moved in. Because if this object wasn't human, and yet displayed structured, targeted behaviour, then it became something more than a curiosity. It became a potential contact. Of course, nothing was said publicly. The CIA doesn't comment on space anomalies. They don't hold press conferences about comets. But the footprint is unmistakable. Observatory bandwidth rerouted through secure relays. Shared sensor logs pulled from public servers. Government astronomers suddenly unavailable for interviews. Silence. Always the first sign that someone powerful is paying attention. Some scientists pushed back. One radio astronomy group in Australia published a brief summary suggesting the pulse was nothing more than a localized albedo fluctuation, trying to downplay the growing interest. But those same researchers later quietly removed their entire analysis, citing a review process. No one claimed interference. But the chill was there, because when an object from outside our solar system emits a light source that behaves like a targeted signal, and when that signal aligns with Earth, it's not just astronomers who take interest, it's the ones who ask, who else is watching, who else knows, and above all, what comes next. That's why the CIA stepped in, not for what we saw, but for what it might mean. The first rule of astrophysical analysis is simple: light tells the truth. Whether emitted by burning hydrogen or reflected from frozen ice, light reveals the nature of the thing that sent it. So when 3i Atlas pulsed on the morning of January 7th, analysts turned immediately to its photonic fingerprint, looking not just at how bright it became, but at how that brightness was constructed, and what they found didn't match anything in the natural catalogue. When a comet brightens, it usually happens one of three ways. 1. Sublimation of volatile gases, like water or carbon dioxide, releasing energy and creating a glowing coma. 2. Fragmentation, chunks breaking off and exposing fresh material. 3. Angular reflection, a change in how the object's geometry catches sunlight. But the light from 3i Atlas didn't behave like any of these. Its spectral profile was too narrow, too structured. It showed signs of intentional modulation. Let's break that down. The flash, measured by 5 observatories and 2 orbital sensors, lasted roughly 6 seconds. But when that signal was split into individual wavelengths, the anomaly appeared not across a broad band of radiation, but in a very specific part of the spectrum, centered near the 400–450 nanometer range, deep blue and near ultraviolet. There was no tail into the infrared, no wide scatter across red or yellow wavelengths. It was clean, focused, and that was the first red flag. Comets reflect sunlight. Sunlight contains a broad, even spectrum of wavelengths. A rough, icy body scatters that light in every direction across every colour. But 3I Atlas didn't scatter, it channeled. Observatories in Mauna Kea and Cerro Paranal both logged what's called a trapezoidal spectral profile. A fast rise, a flat top, and an abrupt drop, like a power signal being turned on and off. Even stranger, within that flat top were ripples, 5 evenly spaced fluctuations, like miniature waves riding on the broader pulse. A deeper analysis of those ripples revealed something even more unnerving: frequency modulation. This wasn't just a flash, it was a pattern. Under software normally used to analyze satellite telemetry, the ripple structure mapped out as a low-hertz oscillation, peaking at a frequency of 5.12 Hz. For comparison, most natural photonic events have chaotic frequency scatter. They burst and fade like static on a radio, but this one oscillated with rhythm, like a beacon. 5m12 Hz is not a random number. That's a frequency often associated with frame synchronization in low-bandwidth optical communication systems. It's slow enough to be deliberate, fast enough to be functional. Engineers use frequencies like that when transmitting basic telemetry, compressed position data, system status updates, or ping signals. So the implication emerged quietly but undeniably. Was this light not just illumination but information? Some argued for solar glint. Maybe a reflective surface briefly caught the sun at just the right angle, but again, the data refused to cooperate. The polarization analysis didn't show broad reflection. It showed angular coherence, meaning the light travelled along a tight cone, not bounced off in all directions. Furthermore, the ultraviolet spike wasn't consistent with ice or dust. Comets don't emit UV, they reflect it poorly. But this spike had amplitude. It had weight. And for nearly a full second it overshadowed the visible spectrum, briefly making the object appear not like a passive body, but an emitter. One telescope at Kitt Peak even recorded a faint redshift in the tail end of the emission, just a microfraction, but enough to suggest the source was moving away from Earth at the moment of fade, meaning the pulse may have been emitted during a slow maneuver or spin, and yet no secondary emissions followed. The object dimmed, stabilized, and returned to its normal coma behavior. No fragments, no dust bloom, just silence. And that silence, coupled with the structured spike, left experts with only 2 uncomfortable possibilities. Either we just witnessed a new, unexplained photonic behavior from a natural object unlike any in recorded science, or 3I Atlas turned something on, something capable of focusing light with unnatural precision, modulating it, and pointing it at Earth. Whatever the truth may be, the signature is recorded now, etched into logs, mirrored in backups, embedded in timestamps, and the only thing more unsettling than that beam of light is the question of what came with it. 9 minutes after the light from 3I Atlas reached Earth, something else arrived. It didn't come as photons or radiation or debris. It came as pressure, an invisible ripple through the upper layers of Earth's magnetic shield, a tremor, subtle but synchronized, and the signature was unmistakable, an echo in the magnetosphere. To the average observer, Earth's magnetic field is silent and still, but to scientists who monitor its fluctuations, especially those working in magnetometry, atmospheric charge measurement and radio propagation, it hums constantly. Solar storms, auroras, and coronal mass ejections all leave fingerprints across this field. But the pulse detected after the 3I Atlas flash didn't match any of those phenomena. It was localized, it was slow, and above all, it was coordinated. 3 stations, one in Alaska, one in Tromsø, Norway, and one in Christchurch, New Zealand, all detected a synchronized low-frequency shift in the Earth's magnetosphere. The reading came as a wavefront, not originating from space in general, but from a very specific vector, roughly aligned with 3I Atlas's position at the moment of its flare. The frequency of the disturbance was measured between 1.7 and 2.4 MHz. This may sound minuscule, but these frequencies are well known in geomagnetic circles. They're called Euler waves, ultra-low frequency oscillations that often ripple through Earth's magnetic shield when it's struck by charged particles or sudden plasma bursts. But what was strange here wasn't just the frequency, it was the timing. Yulf events tied to natural solar wind variations usually come hours after a coronal mass ejection. They're a side effect of solar materials slamming into the magnetosphere. But this wave came less than 10 minutes after a flash of light with no associated solar activity, no flare, no shockwave, no CME, nothing that could explain the cause. Worse, the 3 ground stations didn't just record the pulse, they recorded the same pulse pattern. It wasn't noise, it had structure, a sharp onset, a brief flat line, then an exponential decay that mirrored the optical light curve from 3I Atlas. 2 entirely different systems, one optical, one magnetic, showing identical waveforms across completely different mediums. At first, researchers suspected coincidence, maybe an unrelated geomagnetic event overlapped by chance. But when they compared data from other stations across the globe, they found nothing. The pulse wasn't global. It was hemispherically targeted, appearing only in magnetometer stations that were positioned in the southern night arc at the time of the flash. That's key, because it matched the visibility window of 3I Atlas. This pointed to a spatially directional event. In other words, the magnetosphere didn't just feel something, it felt it from that direction. NASA's Goddard Space Flight Center began analyzing data from the Themis satellites, magnetically sensitive probes that orbit the Earth to monitor auroral and plasma dynamics. At 0331 UTC, 9 minutes after the flash, Themis C recorded a brief spike in magnetotail compression, a contraction of the Earth's magnetic field lines on the night side facing away from the Sun. This kind of movement normally happens during magnetic storms, but this time there was no storm. There was only the pulse. And it came directly through the tail, almost like a wake. One hypothesis emerged quietly among specialists. The light flash may have carried more than just photons. It may have interacted with the heliospheric plasma in such a way that a faint electromagnetic echo was transmitted, either as a byproduct of charged particle excitation or as something much stranger. Because the pulse didn't just ripple, it resonated. At the South Pole Station, instruments detected a brief drop in VLF propagation, very low-frequency radio waves used to communicate with submerged submarines. That drop lasted 3 full seconds, and it occurred, once again, precisely 9 minutes after the pulse. Why does this matter? Because submarine communication relies on global magnetic stability. Any electromagnetic anomaly strong enough to disrupt it, even briefly, must carry an immense amount of coherence. Some theorists propose that 3I Atlas might have interacted with the solar wind in a way we don't understand, acting as a resonant cavity, or a lens, or even a transmitter. That word, transmitter, wasn't used officially. But it appeared in more than one private email chain, because this event didn't just affect the eye, it touched Earth's invisible shell, and in doing so, it suggested a connection no natural comet has ever made, a bridge between light and magnetism, between distance and contact. The object pulsed, and Earth's magnetic field answered. Not all energy announces itself with noise, some reveals itself in heat, and after the light pulse from 3I Atlas, as telescopes returned to routine observations, something subtle but profound emerged from the background. The object had warmed, not evenly, not like a comet under sunlight, but in one isolated sector, and only for a moment, a glow, localized, measured, impossible. It began with the European Space Agency's solar orbiter, using its heliospheric imager, a set of thermal-sensitive instruments designed to track heat signatures near the Sun. The spacecraft had been monitoring 3I Atlas since before perihelion. Most comets show a slow thermal rise as they approach the Sun, absorbing energy, sublimating volatile ice, releasing gas and dust. But 3I Atlas didn't behave that way. Instead, the orbiter recorded a sudden thermal spike in a small region of the object's profile, roughly 400 kilometers offset from its calculated rotational axis. The temperature jumped by over 40 Kelvin in less than 30 seconds. That might not sound like much, but in deep space, where thermal equilibrium is a slow, gradual process, it's a rupture. Even stranger, this heated region was not facing the Sun. In fact, it was on the shadowed side, turned away from direct solar radiation at the time of the observation. That alone was enough to force a reanalysis of every known thermal model, because heat doesn't just appear, it needs a source. Was it stored energy, released from within the object's core? Perhaps internal gas pockets suddenly venting through fractures. That would normally cause spin wobble or mass ejection. But there was no motion, no new jet, no brightness change in the visible spectrum, only a soft, brief glow in the infrared. Telescopes in Chile and the Canary Islands were able to confirm it. When they cross-referenced the exact coordinates provided by ESA, they too picked up the same infrared anomaly, though fainter due to atmospheric interference. But even diluted by Earth's atmosphere, the signal matched. And then, just as suddenly as it had begun, the glow faded. Within 90 seconds, the object returned to its previous thermal state. The area cooled, not gradually, but with a controlled exponential curve. That curve again resembled something artificial. Not the slow diffusion of heat through dust and gas, but the deliberate drop seen in systems with thermal regulation, materials designed to dissipate energy quickly, like radiators or heat sinks. Naturally, scientists tried to explain it away. Some argued that perhaps a bright flare on the sun had briefly bathed the object in high-energy radiation. But when checked against solar activity logs, no flare had occurred in that window. The sun, in fact, was quiet. Others suggested perhaps the glow was the result of cosmic ray bombardment, but that process is diffuse, random, and doesn't concentrate in one clean spot for less than 2 minutes. What remained was an enigma, a brief infrared emission that appeared to follow the earlier flash of light, almost like a secondary stage, an after effect of whatever had been activated. And this wasn't the only time a localized glow had been recorded. Back in late October, as 3 Atlas neared the Sun, a similar but fainter signature had been spotted, but dismissed as instrument error. Now, with corroboration from multiple sources, that earlier event had to be reclassified. In technical terms, it was a transient thermal event. But for those watching closely, it felt like something else. It felt like a test, a system warming up, a subsystem activating. Why would an object, moving at interstellar velocity hundreds of millions of kilometers from Earth, suddenly display behavior that mimics thermal regulation? Why would it glow from within, not once but twice? And why would that glow emerge not from the sunlit side but from shadow? The shape of the infrared signature added to the mystery. It wasn't a point source, it wasn't scattered. It took the form of a crescent, curved, with consistent width. Some likened it to a heat vent. Others saw it as a panel edge or a hatch. The measurements weren't high enough resolution to prove either, but they were enough to unsettle. Because in all recorded cometary activity, nothing like this has been observed. Ever. And as the object drifted onward, past the moment of the flare, past the glow and its aftermath, one conclusion began to surface, quietly, in the back channels between institutions. Whatever 3i Atlas did on January 7th, it was more than visual. It was more than magnetic. It was thermodynamic. It activated something. And now the question hung in space like a second sun. If it glowed once, would it glow again? The data from the South Pole Infrared Observatory came in fast. What was expected to be routine background noise had, in the span of just 5 hours, turned into an escalating anomaly. The observatory's sensors weren't built to track moving objects like 3i Atlas across visible skies. They were optimized for thermal emissions, energy signatures that fall outside human perception. But what they recorded on the morning of January 7th broke pattern in a very specific way. Not only was 3i Atlas glowing, it was emitting structured pulses in the infrared band, sharp, clean, rhythmically spaced. Normally, a comet's glow comes from passive interaction, sunlight reflecting off its nucleus or dust, or thermal reactions as solar radiation hits ice. But this wasn't diffuse, it wasn't scattered. These pulses behaved more like signals, tight bursts that began to mirror patterns typically seen in deep space communication attempts, only translated into heat signatures rather than radio frequency. A flash, a pause, a double pulse, then silence, then it would start again. Researchers cross-referenced the data with other ground-based observatories across Chile, Australia, and the Canary Islands. To everyone's surprise, none of those facilities recorded the anomaly in the same way. In fact, some didn't pick up anything unusual at all. That's when the realization sank in. This wasn't just a general glow that anyone with the right telescope could see. It was directional. The pulses were being emitted in a narrow infrared beam, aimed not in every direction but in one, toward Earth. At first, some believed it was just coincidence. After all, space is vast, and directional heat could still be natural if the comet's rotation caused a jet to flare in alignment with its movement. But that theory unraveled when the timing was mapped out. The pulses only aligned with Earth's orientation during specific orbital overlaps, small windows where the planet's rotation matched the comet's angular velocity. This meant something chilling. The pulses weren't simply happening, they were being timed. Satellite data from a weather monitoring station in low Earth orbit recorded a spike in atmospheric infrared reflection during the same window. While the temperature fluctuation was barely detectable, it matched perfectly with the South Pole data in frequency and rhythm. The pulses weren't just visible in space, they were being felt here, in our own upper atmosphere. Suddenly atmospheric physicists found themselves in high-level meetings. Not because the energy posed a danger, it didn't, but because of what it implied. If a structure in space could project such precise, timed pulses to a rotating planet, hundreds of thousands of kilometers away, then it must have some knowledge of Earth's motion. Not only that, it had adapted to it. This sent a shockwave through the intelligence community. To pulse heat in rhythm with the planet's spin requires a dynamic awareness of planetary mechanics. That alone meant intelligence, if not in the biological sense, then in engineering. The comet's structure, its orientation and its rhythm seemed too calculated for randomness. And then came the optical twist. When researchers enhanced optical imaging of 3I Atlas during the same pulse windows, they noticed a flickering visual echo, an illusion that only appeared when overlaying visible and infrared feeds. The light, when observed in tandem across multiple spectrums, showed a structured alignment, almost like rotating panels or shifting architecture, modulating in sync with the pulses. That illusion wasn't visible to the naked eye, but to machines it looked like movement, deliberate, synchronized movement. The theory was simple but staggering. 3 Atlas was using light, infrared light, to signal, to align, to project. Not like a flashlight, but like a lens with purpose. And those who knew how to look, knew what band to observe in, could see something far more complex than a glowing rock. They could see design. Just after the pulses had been catalogued and confirmed to be directional, something even more bizarre emerged. Something that had never been associated with a comet before. Not magnetic anomalies, not optical illusions, but spatial distortion in the form of holographic interference. The discovery didn't come from NASA or ESA. It came from a quiet observatory in Sapporo, Japan, where a small research team had been using a phased laser array to study distant gravitational lensing phenomena. Their instruments weren't aimed at 3 Atlas directly. In fact, the object was almost an afterthought in their study. But during a calibration sweep meant to test background field coherence, something odd happened. Their readings showed interference patterns, not in space, but in the airspace around 3I Atlas. At first, the team thought it was equipment failure. After all, interference patterns, like the ones caused in double-slit experiments, shouldn't happen on a cosmic scale unless an extremely precise, coherent source of radiation was involved. But when they reran the sweep, the interference was still there, and this time, the pattern moved. The ripple wasn't random. It expanded and contracted in perfect symmetry with the object's rotational timing. The gaps between the holographic lines increased every time the object passed between Earth and the Sun, and then shrank as it rotated out of alignment. This suggested something extraordinary. 3 Atlas wasn't just reflecting light, it was shaping it. Experts in optics were brought in. Laser physicists, field theorists, even experimental engineers from DARPA and Japan's Advanced Photonics Research Center. They all saw the same thing in the raw data. A controlled high-coherence field was being generated, and it wasn't atmospheric, nor solar, nor terrestrial. It was originating from the object. There are only a few known ways to produce structured holographic patterns across vast distances. One involves phase-locked lasers with extreme stability. The other involves manipulating the electromagnetic fabric of the surrounding space. And that second possibility was the one that matched best. Because when the researchers overlaid their interference maps with gravitational field simulations from ESA's Gaia mission, something clicked. The wavefronts of the interference lines weren't random. They coincided perfectly with local gravitational nodal points. In short, the interference wasn't visual alone, it was gravitational optical, a type of effect no natural comet has ever been known to produce. And then came the deeper twist. In a final test, the Sapporo team attempted a backtracing algorithm, using the known velocity and rotation of 3I Atlas to simulate what the field should look like if it were generated intentionally as a kind of spatial projection array. The simulation matched too perfectly. In their words, it was like looking at a moving lens system in deep space, an array of optical projectors orbiting a rotating spine. They weren't suggesting a hologram in the science fiction sense. No fake object, no false projection. What they were suggesting was far stranger, that 3 Atlas was wrapped in a dynamic interference field, not unlike those used in advanced stealth or cloaking technologies. Except this wasn't to hide the object, it was to modulate its visibility, to alter its profile in different bands, infrared, microwave, ultraviolet, even gravitational. Some now believe that the visible object we've been calling 3I Atlas may be only a partial representation of its true structure, just one layer of a multidimensional system using holographic field control to regulate what gets seen and when. As word spread, intelligence agencies began issuing quiet alerts. This wasn't just about light or rotation or tail structure anymore. We had just detected a level of field coherence that, on Earth, would require an entire city's power grid, and it was coming from a single object. Floating, turning, watching. A projection, a disguise, or a signature. Whatever it was far more advanced than anything we had ever seen in space. Following the holographic interference patterns, researchers hoped for a stable pattern they could monitor over time, something predictable. But instead they got the opposite. At 0214 UTC, over a dozen global deep space monitoring arrays, ranging from Green Bank in West Virginia to the European Space Operations Center in Darmstadt, reported the exact same anomaly. A dropout, not a communications dropout. Not a loss of visual tracking, a frequency blackout. To understand how unusual this is, you have to realize that even the coldest, quietest objects in space emit energy. They radiate in infrared, reflect sunlight, interact with background microwave radiation. Every known body has a profile, a signature, a thermal fingerprint. But for a full 67 seconds, 3I Atlas stopped emitting anything. No passive infrared, no radio echo, no detectable microwave scattering. Instruments calibrated to even the faintest cosmic background radiation, designed to pick up signals billions of years old, recorded a blank spot where 3I Atlas should have been. Not dim, not cloaked, absent. The term used by technicians wasn't scientific. They called it a void spike, a sudden artificial dip across multiple channels that created a silhouette of absence, a ghost in the spectrum. What made this terrifying wasn't just the dropout, it was what came after. Exactly 67 seconds later, the signal didn't fade back in gradually. It came back all at once, with a high-frequency spike that exceeded the amplitude of any previous readings. The waveform was unlike anything they'd seen. Not a pulse, not a natural harmonic. It was layered, like two different frequencies had been recorded on top of each other, only distinguishable after advanced filtering. Signal analysis labs in France, India, and Australia ran independent decompositions. Here's what they found. One frequency was a perfect Fibonacci harmonic, a pattern found often in both organic structures and in theoretical models of optimal data transmission across noisy channels. The other frequency was logarithmic, following a decaying curve that matched patterns used in compression algorithms. Why does that matter? Because the combination of Fibonacci-based harmonics and logarithmic decay is something you'd expect in engineered signal encoding, not in natural objects. The interpretation was not definitive, but a word kept creeping into reports. Compression. Something was being stored, transmitted, or decoded. Not only was 3I Atlas broadcasting again, it seemed to be carrying a payload of structured information in bursts. If that wasn't enough, a more chilling implication emerged from the data. The frequency blackout may not have been accidental. It may have been deliberate calibration. Researchers proposed a theory now gaining traction, that 3I Atlas turned itself off to test what Earth's sensors would do. what frequency bands were used to track it, which observatories picked up the anomaly, and how fast the global network responded. It would be a kind of active probing, analysing the observers. In cybersecurity, this is known as fingerprinting the enemy, testing defences by briefly disappearing and watching who notices. NASA won't confirm the theory publicly, but internally the incident was flagged with a Tier 3 anomalous event report, which is normally reserved for failed re-entries or intentional jamming from hostile satellites. But this wasn't a satellite, it was a comet, and yet one that could manipulate its signal footprint, choose when to be seen, and adjust its transmissions after testing our detection grid. From that moment on, people stopped calling it just a comet, because this was something else entirely, something aware. By now, most scientists had abandoned the idea that 3I Atlas was just a hyperactive comet with a few odd behaviours. The blackout event changed everything. And what came next, triggered by a series of high-resolution spectroscopic scans from the James Clerk Maxwell Telescope in Hawaii, forced astrophysicists to re-examine their most basic assumption, that the glowing heart of 3I Atlas was a core at all. It had always been treated like one, a nucleus, however strange, surrounded by jets and shedding layers. But after combining readings from infrared sensors, magnetic flux detectors, and gravimetric lensing from ESA's solar orbiter, the emerging data told a different story. The central region of 3I Atlas wasn't solid. It wasn't dense, it wasn't even behaving like a mass with inertia. Instead, it was oscillating, not just in brightness or electromagnetic output, but in gravitational field strength. Over a 31-minute scan window, the core appeared to breathe in gravitational terms, its field expanding and contracting in a regular pulsed rhythm. This alone was enough to defy current physics. No known natural object can modulate its gravity like this, not without collapsing or fragmenting. But there was more. As the pulses were mapped, another disturbing pattern emerged. They weren't random. The fluctuations followed a sequence. Prime numbers embedded in the timing intervals, that's right. The time between each pulse wasn't chaotic. It followed a prime sequence. This sent shockwaves through the physics community. Prime number patterns do not occur in natural gravitational fields. They're not the result of chaos theory or thermal variation. They're mathematical, pure, and most importantly, intentional. And that raised a terrifying question. What kind of object modulates gravity using prime number encoding? The working theory presented at a classified JPL session was as bold as it was unprecedented. The core wasn't a solid body. It was a gravity shell, possibly hollow, possibly a containment structure for something else. A field-generated envelope, like an artificial womb, adjusting itself based on proximity to other gravitational sources, and the shell was now responding to Earth. Gravitational echo tests showed something even more disturbing. When Earth's mass exerted a field pressure as the comet approached, 3I Atlas began to match it, slightly delay it, then invert it. Not in terms of polarity, but in pattern. It was learning our gravitational pulse, our planet's fingerprint. The unique way Earth breathes gravitationally, due to its density variations and rotation. Imagine that. An object learning to mimic the gravitational rhythm of Earth. And if it could do that, what else could it do? Some began comparing it to a sonar echo, like a submarine testing the shape of an ocean floor. But others saw something darker, a countermeasure, as if the structure was calibrating its own field to either shield against Earth's influence or prepare for entry. At Los Alamos, a theoretical team fed the oscillation data into a model of active field shielding, essentially a way to cancel out the gravitational pull of a large body using timed pulses. The simulation showed that if the sequence continued, 3I Atlas could eventually nullify Earth's pull on its own mass. In other words, it could approach without falling in. No slingshot, no orbital decay, no atmospheric friction. It would just hover, parked, like a probe waiting for permission to land. This was not just a comet anymore. This was an engineered gravity envelope pulsing in primes, syncing to Earth's own signal, and possibly getting ready to descend. And it wasn't hollow by accident, it was hollow by design. As the days passed, researchers stopped asking whether 3I Atlas was natural. That debate was over. Instead, their focus shifted to something far more unnerving. Why couldn't we see inside it? Every high-energy instrument thrown at the object, X-ray arrays, deep spectrum interferometers, synthetic aperture scans, hit the same wall. The outer shell of 3i Atlas deflected, refracted, or absorbed nearly every probing signal, regardless of wavelength. At first, this was thought to be due to extreme dust activity or dense ionized gas jets, but once data from the Chandra X-ray Observatory and ESA's Integral Gamma Ray Telescope were merged, the story changed. This wasn't random opacity. This was selective cloaking. The emissions escaping from 3i Atlas weren't consistent across viewing angles. Instruments positioned at different longitudes around Earth reported conflicting data. One telescope saw a sharp drop in infrared signature, while another, just 6,000 kilometers away, detected a burst. When these readings were mapped and overlaid, something became clear. 3i Atlas was rotating a cloaking field, like a lighthouse beam, but designed to scatter or cancel observations depending on vantage point. It meant that the object wasn't just shielding itself from random detection, it was controlling who saw what. That possibility ignited panic behind closed doors. In intelligence circles, this was interpreted as a form of counter-surveillance camouflage, not unlike radar jamming or stealth technology. But no known materials, natural or synthetic, could account for the behavior. This field wasn't passive, it was dynamic. So a new term emerged in the astrophysical briefings, cloak field, and that theory opened a door no one was prepared to walk through. What if 3i Atlas had been seen before, but we never noticed? What if it had passed through this system, ours or others, multiple times, and each time simply cloaked itself to avoid detection? With a dynamic field, it could remain nearly invisible to any civilization that hadn't yet developed multi-angle deep field mapping. This wasn't just a shell, it was an intent filter, a gatekeeper deciding what you got to perceive. JAXA and the Indian Space Research Organisation attempted a novel workaround, gravitational lens triangulation. By using Mars' position to act as a secondary lens, they aimed to bend light from behind 3i Atlas to see through the shell via backscatter. What they discovered shook the team. At the exact moment of alignment, the object vanished, not literally, but optically and gravitationally. The mass signature disappeared, light refracted in impossible curves, and quantum noise on the instrument spiked. There was only one explanation. The object had detected the triangulation attempt and responded. By the time alignment broke, the mass signature was back, along with a brief spike in low-frequency radio noise, almost like a static burst. But hidden inside that burst was something chilling, a frequency-modulated harmonic that matched the deep-sea sonar ping used by nuclear submarines. One ping, one response. This left the teams with two equally terrifying possibilities. Either 3i Atlas was cloaked by a self-stabilizing reactive field, or it had a pilot, a consciousness, or something even more disorienting, a field intelligence. Not a being inside the object, but the field itself behaving like a mind. Quantum computing labs scrambled to model what that would mean. Could a field, an electromagnetic veil around a structure, develop recursive logic? Could it become aware of its observers, adapt in real time, make decisions about what to show? MIT physicist Dr. Hee-Jin Seo put it this way during an internal press briefing. If you're asking me whether the cloak field thinks, we can't answer that, but I will say this. It acts differently depending on who's watching, and the last time that happened in our experiments we called it the observer effect in quantum mechanics. Others started calling it something else, intent camouflage, not just to protect, but to manipulate perception, to choose the story we see. And if it could decide what we see, what else was it hiding? The first transmission didn't come through a telescope, it came through a cable buried under the sea. At precisely 3:37 Coordinated Universal Time, fiber optic sensors attached to a transoceanic communications line between Japan and California recorded a burst of electromagnetic interference that, on the surface, looked like a common anomaly. At first, technicians thought it was a relay issue, perhaps caused by undersea volcanic activity or a passing solar flare. But when the data was replayed at a slower rate, filtered through spectral decomposition software, and inverted for waveform harmonics, something impossible emerged: structure. The noise wasn't random, It mirrored known encryption initialization pulses, the kind used to begin secure military communications. Only this wasn't from any military. It came from 3i Atlas, not from a radio dish, not from a laser beacon, but through the Earth itself, piggybacking on our infrastructure. The burst had latched onto magnetic harmonics from the comet's own wake, using the ionosphere as a carrier medium, travelling down through the crust and hitchhiking across undersea cable shielding. It didn't transmit information in the traditional sense. It stimulated the environment to encode data in its response. The implications were staggering. This wasn't just energy. It was deliberate, engineered. Astrophysicists from the International Data Relay Consortium were immediately called into an emergency closed-door session. Experts in machine learning, cryptography, and signal theory were brought in from every corner of the intelligence world, many under silent contracts. They weren't told where the data came from until after the third hour of the session, and then everything changed. They discovered that the data spikes aligned with geosynchronous satellite windows. Every time Earth rotated into a specific orientation, the pulse from 3i Atlas's internal structure seemed to adjust, compensate, timing its burst to coincide with maximum signal capture potential. It meant one thing. The structure wasn't just emitting energy randomly, it was targeting Earth, or at the very least calibrating its emission schedule based on Earth's location and rotation. But what made the surge even stranger was how Earth responded. Local magnetosphere sensors began detecting strange low-frequency harmonics. These weren't audible in the traditional sense, but they resonated with instrumentation used to measure atmospheric charge, satellite latency, and deep-sea cable current variability. The phenomenon was global, synchronized, and growing stronger by the hour. The clearest readings came from three places: the Norwegian Svalbard facility, an underwater array off the coast of Guam, and, most disturbingly, an abandoned Soviet listening post in Siberia that had been reactivated only weeks earlier. When the data streams were layered, something emerged that no one could explain. A fingerprint. Each burst, each harmonic wave, each global resonance pulse mapped perfectly to an audio visualization pattern known as a spectral echo loop. These loops are often seen when a recorded message is intentionally layered to resist distortion or compression, the kind of method used by deep space probes trying to broadcast through radiation storms, except this wasn't coming from a probe. And the shape of the loop, when rendered visually, did something else no one expected. It repeated. Every 108 minutes, exactly the time it takes for a low Earth orbit satellite to complete a full rotation around the planet. It was as if 3i Atlas had timed its communication pattern to our satellite grid, to our technological infrastructure. It wasn't just reaching out, it was listening back. One analyst from the US Defense Communications Division put it bluntly: "We didn't pick up a signal, we intercepted a reply." But a reply to what? That question tore through every lab, every secure facility, every underground think tank that had been looped into the discovery. Had we already sent something, accidentally or otherwise, that 3i Atlas was now responding to? Or worse, was it answering a call not meant for us? A transmission never intended for human ears, a loop in the dark set in motion long before we even had radios. And now that we'd heard it, there was no way to unhear what came next. As the artificial light source near 3i Atlas continued to pulse in silence, a new layer of complexity emerged. Not from the comet itself, but from one of humanity's most reliable eyes in space, the Hubble Space Telescope. On January 7th, at approximately 4:30 in the morning Coordinated Universal Time, Hubble captured a sharp, glinting anomaly as it passed its scheduled window to scan the vicinity of the object. At first, astronomers believed it was a camera artifact, a common optical issue when bright stars cross into frame. But this was different. The light wasn't coming from a predictable celestial body, and it didn't match any known reflection pattern associated with space dust, solar lensing, or ice. Instead, what was observed was a split-second flare, not unlike the refraction from a spinning mirror, except it came from deep space, originating near the coordinates associated with 3 Atlas's trailing side. Within the hour, data analysts began sifting through the raw telemetry. Spectral analysis revealed that the signature of this glint carried an unusual wavelength shift, something between ultraviolet and soft X-ray emission, but with a refractive profile too structured to be random. What this implied was chilling. The light wasn't being merely emitted, it was being bent, focused, altered. This small shift led to a larger hypothesis inside the Hubble processing room. Could the light source activated by 3i Atlas be part of a larger optical system? Something capable of manipulating external light? That would suggest not just the emission of light, but active modulation, akin to a laser array or a scanning beacon. In other words, the light wasn't simply shining outward like a flashlight in space. It was behaving more like an adjustable mirror, capable of directing or splitting light depending on orientation. That would imply machinery. But here was the paradox. No heat signature accompanied the flare. No thermal bloom, no residual ion trail. Just light, split unnaturally and caught, accidentally or not, by one of Earth's most advanced telescopes. When engineers compared the angle of incidence with Earth's orbital position, the geometry didn't make sense. For Hubble to have seen that flash, 3i Atlas's reflective point would have needed to pivot mid-course toward Hubble's path. And yet the comet's trajectory hadn't shifted, not even slightly. There was a growing suspicion among the observatory's team that this wasn't a random orientation. It was a moment of alignment, as if 3i Atlas had not only activated an internal light source, but also extended something capable of responding to external observation, a responsive, optical surface. If that were true, then something on board 3i Atlas had recognized it was being watched. It was during these meetings that a small anomaly was raised from the archival logs. Months earlier, during a pre-perihelion flyby from a small French observatory, a similar lensing distortion had been spotted. At the time, it was dismissed as an imaging glitch. Now, it was revisited and reprocessed through the new lens of hypothesis. This wasn't the first time 3i Atlas had refracted light abnormally. It was simply the first time we noticed it for what it was. The word lens was now being quietly passed between analysts and astronomers. A lens that had no organic origin. A lens that responded. As the hours passed and Hubble moved on to other targets, the glint never repeated. No further reflections were recorded. It was as if the system aboard 3i Atlas had pulsed once, been seen, and then retracted. But for the experts who caught it, that moment would linger. Because the comet didn't just shine, it blinked. For a full 24 hours after Hubble's unexpected capture of the refracted glint near 3i Atlas, scientists worked under the assumption that they had witnessed a spontaneous, perhaps accidental, optical event. But the deeper they dug into the timestamp, the harder it became to accept randomness. That single blink, a narrow, focused flash of modulated light, had occurred at exactly 4:33 a.m. UTC. Not earlier, not later, but precisely at the moment when Earth's night-side hemisphere, over the South Atlantic, rotated into optimal signal reception from geostationary satellites. This detail was flagged not by astronomers, but by engineers from the European Space Agency's Communications Division, who had been cross-monitoring satellite signal stability due to recent solar wind fluctuations. At 4:33, multiple satellites in Earth's geosynchronous belt recorded microsecond signal noise spikes. They were brief, but synchronized across multiple systems. Initially written off as background radiation from solar refraction, the pattern was reanalyzed when overlaid with Hubble's observation timeline. What emerged was unsettling. The satellites and the Hubble telescope, separated by hundreds of thousands of kilometers, had detected disturbances aligned to the same moment within the same second. This led to a more sobering question. Was the blink not only visible, but aimed? In emergency sessions, international astrophysics teams used light path simulations to reconstruct the trajectory of the flash. If the blink from 3 Atlas had been a simple act of internal light emission, the signal should have dissipated outward uniformly. But it hadn't. The beam had been narrow, directed. Its angle of dispersion intersected both Hubble and Earth's geosynchronous arc, specifically the communication corridor covering the South Atlantic and parts of sub-Saharan Africa. And that meant timing wasn't an accident. The internal light mechanism aboard 3i Atlas had pulsed in alignment with Earth's rotation, its satellite's orientation, and Hubble's scanning pass. To achieve that level of precision would require computation, prediction, and above all, intent. So what exactly was the purpose of the blink? 3 main theories began circulating through classified scientific circles. Theory 1, calibration. The blink could have been a calibration flash, similar to how human spacecraft test directional beacons or navigation lasers when entering a new orbital environment. If 3i Atlas was mapping Earth, its satellites, or even solar vectors, a single brief pulse could help measure latency, angle deflection, and signal echo time. Theory 2. Communication attempt. The more controversial theory suggested that the blink was an intentional signal, a narrowband optical communication attempt aimed either at Earth or at another object along the same corridor. In this view, Earth wasn't the target, it was the relay. The comet may have been broadcasting towards something else entirely, possibly a satellite in deep space, or even something still hidden. Theory 3. Confirmation of observation. This was the most chilling theory, that 3 Atlas was aware of Hubble's presence, aware of the rotation of Earth's satellites, and had responded in kind. A blink not just to be seen, but to acknowledge being seen. A technological form of eye contact. Whichever explanation proved true, the implications were the same. 3 Atlas wasn't just active, it was coordinated, operating on celestial timing. Responsive to human observation windows. This elevated the object from an anomaly to a controlled system. As the global network of observatories reoriented toward the object, orders were given for continuous round-the-clock observation, this time not only in visible light but in radio, infrared, and high-frequency plasma resonance bands. No one wanted to miss the next blink, if there was one, because now every second felt scheduled, every pulse potentially rehearsed. The universe, once thought to be indifferent, had just done something unnerving. It had winked. In the hours following the documented blink from 3 Atlas, engineers and physicists began cross-referencing everything they could. Electromagnetic interference logs, satellite telemetry, even retired orbital relays that hadn't transmitted anything in years. What they found buried in the noise was more than just signal distortion. It was a shape, and it matched the blink. It began with a routine diagnostic at the European Space Agency's Deep Space Listening Post in Gebreros, Spain. Technicians there were reviewing real-time signal integrity logs for their geostationary relay satellites when they noticed something odd. An echo signal had bounced back through multiple communication channels at precisely 4:33 a.m. UTC, the same moment the Hubble telescope recorded the brief emission near 3i Atlas. At first, it seemed like a hardware glitch. Echoes in high-orbit systems aren't uncommon when multiple satellites cross similar paths or when solar storms create interference fields. But when they ran the waveform through Fourier transform analysis to extract hidden patterns, the signal's harmonic envelope began to show something deeply strange. The returning pattern mirrored the spatial intensity profile of the blink itself. Not just a match in timing, but a match in form. In simpler terms, the reflected signals weren't just distorted, they were sculpted. The pulse that had emanated from 3i Atlas had somehow imprinted its shape into the very echo coming back through Earth's satellite corridor. That shouldn't have been possible. Light, especially at those distances and durations, doesn't leave behind a signature in echoes. And yet, every satellite in the South Atlantic communications corridor had experienced a faint but detectable resonance that aligned perfectly with the blink's brightness curve. When visualized in three-dimensional space, the pattern formed what researchers later called a folded triangle, a sharp, angular profile with 3 energy peaks rising from a sloping baseline. That shape had never been seen in natural interference. It was neither a product of cosmic radiation, nor of solar reflection, nor of atmospheric distortion. It was intentional, or at the very least, engineered. So what did it mean? The working hypothesis from a coalition of data scientists and aerospace theorists was this. The blink wasn't just meant to be seen, it was designed to echo. The signal had been pre-shaped so that, when it hit Earth's geosynchronous corridor, it would reflect in a pattern decipherable only if someone was listening on very specific frequency bands, at very specific times. This changed the equation entirely. If the signal was engineered to leave an echo, then it had a built-in replay function, one that only activated when the geometry between Earth, its satellites, and 3i Atlas was perfectly aligned. This suggested a level of computational foresight far beyond anything expected from a natural object, even one behaving oddly. Even more unsettling was the discovery that the folded triangle shape matched a faint pattern, picked up by the Chinese Tiangong 2 station a week earlier during a narrow band scan of polar orbit communications. At the time, the shape had been dismissed as background telemetry. Now it looked like a precursor signal, a breadcrumb. Global agencies quickly pulled older satellite logs, looking for earlier versions of the shape. Partial forms, incomplete triangles, signals that had been growing in strength as the object drew nearer to Earth, and they found them. Weak. Fragmented, but real. What emerged was a timeline. The folded triangle hadn't just appeared during the blink, it had been building layer by layer for weeks. And now, at its peak moment, it had reached full coherence, etched into the sky, bounced between satellites, and absorbed by systems built for human communication. This wasn't light randomly hitting Earth. This was a signature sent through time, bouncing off our technology, encoded into our machines. And it left scientists with a single, echoing question. If this was a signal, who, or what, was supposed to answer it? While the folded triangle pattern echoed through satellite corridors, another layer of mystery unfolded within the world's signal forecast systems. For decades, global agencies like NOAA, ESA, and China's National Space Science Center had maintained predictive models for signal behavior, solar flare impact forecasts, ionospheric absorption levels, and magnetospheric reflection indices. These maps, largely invisible to the public, are critical for everything from submarine communication to spacewalk safety. But on the morning following the blink, a cluster of signal analysts in Boulder, Colorado noticed something deeply strange. The forecast models weren't just reacting, they were predicting. An anomalous series of signal shifts had been pre-mapped into the system before they even occurred. Dr. Lila Mercer, a lead wave theory expert at NOAA, was the first to connect the dots. She'd been tracking the blink echo across multiple bands when she cross-referenced the signal evolution with internal signal interference forecasts. Her expectation was to find deviations, aberrations, but what she found instead was eerie alignment. The forecasts, automated and based on machine learning algorithms trained on decades of space weather data, had already predicted the precise minute of the blink's energy curve shift. That shouldn't have been possible. Forecast models are probabilistic. They don't predict isolated optical or electromagnetic events with that kind of precision. Yet this one had drawn a perfect anticipation of the fold intensity rise nearly 22 hours before it happened. Digging deeper, Dr. Mercer overlaid 5 days' worth of forecasts onto a sequence chart from the 3i Atlas telemetry pool, and that's when the pattern began to emerge. Each day's forecast had, hidden in the noise, a temporal alignment with a growing number sequence. The intervals weren't random, they were shrinking, slowly, deliberately, a nested sequence of energy spikes and troughs, forming what looked like a countdown. A countdown to what? At first, the idea sounded ludicrous. Forecast models don't carry embedded countdowns, but when they simulated future forecasts using past input data, and still saw the countdown persist, it became clear that something else was at play. It wasn't the models predicting 3i Atlas. It was 3i Atlas influencing the models. This revelation sent shockwaves through the room. Could it be that the object had been shaping the electromagnetic environment so precisely, so subtly, that even our AI-based forecasting systems were being led to anticipate its behavior? The implications were terrifying. If the blink was engineered, and if its signal created echoes that shaped our forecast tools, then it meant one thing. 3i Atlas was not just observing Earth, it was training Earth systems to respond. Further analysis revealed that the countdown sequence had multiple inflection points, moments where the intensity of expected interference would spike just slightly earlier than the model predicted. These spikes, upon closer inspection, matched key orbital alignments. When Earth, its moon, and 3i Atlas crossed into particular gravitational harmonics, it was as if the object had built a kind of cosmic metronome, one Earth's machines were unknowingly syncing to. And then came the most disturbing find. At the end of the forecast window, just 4 days out, there was nothing. No interference, no baseline, no prediction data, just a blank slice. Systems that had never gone dark before were suddenly silent in their projections. It was as if the countdown reached zero, and the machines didn't know what came next. This wasn't a glitch. The forecast engine was operational, but it had no reference for what it was being asked to see. A growing chorus of researchers began to whisper. The silence wasn't absence, it was an instruction. A void that had been built into our systems long before we realized we were part of a pattern. And as the blank window approached, the question returned, sharper than ever. If this was a countdown, what happens when it ends? And why had we only just now noticed that we were the ones counting? While analysts at Knowaway and ESA struggled to decode the countdown embedded in forecast maps, an entirely different team working out of Istanbul uncovered something no one had expected. The echo patterns from 3i Atlas were aligning with ancient terrestrial coordinates, and not just randomly, but with a strange mathematical fidelity that couldn't be dismissed as coincidence. Dr. Erin Kaya, a geospatial historian with a background in archaeoastronomy, had been following the 3i Atlas signal phenomenon not from a lab, but from the ancient stone observatory at Mount Nemrut. Her team had been mapping the blink's reflected echo patterns on a hunch that perhaps these weren't just astrophysical emissions, but geocentric signals targeting specific Earth locations. To test this theory, Kaya overlaid the echo bloom intensities on a topographical map of the Earth. Then she added a new layer, sites of ancient observatories, megalithic structures, and mathematically aligned temples, from Teotihuacan to Göbekli Tepe, from Nabta Playa to Giza. What she saw made her sit back in silence. The pattern wasn't just close, it was precise. The highest resonance nodes from the blink's reflected signals landed directly over ancient sites that had long been associated with celestial alignments, places where humans once tracked stars, built calendars, and buried rulers in harmony with solstices and lunar phases. And there was more. Each echo pulse seemed to resonate along longitudinal paths that mimicked ley lines, hypothetical alignments drawn between spiritual or ancient landmarks. Ley lines had always been dismissed as pseudoscience, but now they were lighting up on spectrographic data visualizations, infrared, ELF frequency plots, even magnetometer echoes. The blink wasn't just bouncing off Earth's magnetic field, it was interacting with the architecture of ancient Earth, and the timing, perfectly synchronized with the Earth's own geomagnetic wobbles, subtle shifts in the planet's core orientation that had been accelerating over the last 18 months, ever since 3i Atlas had entered the solar system. The closer it came, the more precisely these echoes aligned. Dr. Kaya's team proposed a controversial hypothesis, that the object was not simply reacting to Earth, but to something we had already built, or rather, something that had been built long before us, structures that had outlasted languages and empires, now humming back to life through a cosmic trigger. She reached out to linguistic historians and pattern theorists, and together they noticed something even more bizarre. The intervals between major echo nodes, where the signal amplified the strongest, matched ratios found in ancient calendars, the Mayan long count, the Sothic cycle of ancient Egypt, and the lunar solar calendars used by Babylonian astronomers. In other words, the blink didn't just resonate in space, it resonated in time. Kaya called it the echo grid, a matrix that connected space, frequency, geography, and deep historical rhythm. And at the center of that grid was a node that hadn't lit up yet, a blank coordinate in the southern Pacific Ocean. Remote, empty, over 1,000 kilometers from any known civilization. But according to the signal pattern, that's where the next major echo bloom was going to converge within 72 hours. The implications tore through the global science community. If ancient humans had somehow built structures that could resonate with signals from deep space, signals that hadn't arrived until now, then either it was an unfathomable coincidence, or something had instructed them, something that knew the object would one day return. The echo grid wasn't just a scientific curiosity now, it had become a map, a blueprint, and somewhere on that grid the next phase of contact or collision was about to begin. Because the echoes were no longer fading, they were converging, and each pulse now carried a tone scientists could no longer classify, one that didn't match any known harmonic on Earth. It sounded less like a reflection, and more like a reply. As the echo grid became the centerpiece of every astrophysics dashboard on Earth, one node on the grid grew hotter, more active, more deliberate than all the rest. A remote point in the Southern Ocean. Not a city, not a research base, not even a buoy. Just water. empty, freezing, and seemingly insignificant. But the data said otherwise. Each time 3i Atlas pulsed, the convergence of reflected signals tightened around this one geographic coordinate. What began as a vague magnetic disturbance had, over the last 48 hours, narrowed into a nearly perfect spiral, a helix of electromagnetic compression that satellites began picking up in increasing resolution. The convergence zone was centered at 59.1 degrees south, 115.4 degrees west, just north of the Antarctic circumpolar current, windswept, lethal, a place no man had reason to sail, no nation had ever claimed, and no known anomaly had ever been reported, until now. The first to respond wasn't NASA or ESA. It was a joint task force from Chile's Naval Meteorology Division and a French oceanographic satellite, Jason 4, that had just happened to be flying overhead. At precisely 3:47 UTC, both systems independently recorded something impossible. Sea level in the convergence zone rose by 3.2 meters over a radius of 10 kilometers, with no atmospheric pressure changes, no seismic activity, and no lunar tide interaction. It was as if the ocean swelled, not from underneath, but from a force pressing down from above. And then came the temperature spike. Deep-sea sensors picked up a plume of warmth rising from 2,000 meters below the surface. Not geothermal heat, but electromagnetic energy, the kind that charges ionosphere layers or alters magnetosphere flow. Only this was underwater, and rising. When NOAA rerouted a satellite to do a pass over the area, they expected fog, sea spray, maybe cloud distortion. What they got was a symmetrical ring, an actual circular clearing in the cloud cover, perfectly centered over the convergence point, spinning slowly, reflecting radar pulses like a rotating metal surface. That's when global military organizations took over. Reports surfaced, quietly, of a US drone craft being deployed from Diego Garcia under emergency launch codes. Not a standard MQ-9 or ISR platform, something new, something classified. Its purpose wasn't to observe, it was to scan, to listen. Its sensors had been tuned specifically for the frequencies echoing from 3i Atlas. It was equipped not just with imaging tech, but with decryption algorithms, and what it found sent shockwaves through Washington. The water itself was vibrating, not visibly, but molecularly. At the edge of the convergence point, just beneath the surface, a ring of energy oscillation was forming, as if the sea was being used as a medium, like a lens or a relay dish. The implication was staggering. What if the Southern Ocean wasn't the target? What if it was the amplifier, a place carefully chosen for its isolation, conductivity, and magnetic positioning, where a signal could either be received or launched? As the countdown clock from the NOAA simulation ticked closer to zero, experts across multiple observatories began to suspect something they had avoided saying aloud. This wasn't a natural encounter. It was a rendezvous, not with humanity, but with the planet itself. 3i Atlas had not chosen a population center, or a magnetic pole, or a satellite corridor. It had chosen the one point on Earth where the oceans were deepest, the winds were most hostile, and no one was watching, until now. And at the center of it all, the water continued to rise, not in chaos, but in symmetry, as if obeying a signal no one had yet translated. While Earth's military and scientific apparatus focused its attention on the Southern Ocean Convergence Zone, another effort was underway, quieter, more cerebral, and perhaps even more important. At MIT's Lincoln Laboratory, a new branch of signal theory was being tested in real time, not to decode language, but to interpret behavior. Because the pulses from 3i Atlas were not linguistic in the traditional sense. They carried no words, no repeating syllables, no frequency patterns that resembled known alphabets or code books. Instead, they moved like decision trees, branching patterns of pressure, resonance, and harmonic overlap that shifted based on Earth's own magnetic feedback. Each time Earth's field changed, 3i Atlas adjusted its emissions accordingly, like a conductor responding to the orchestra, not controlling it. The lead theorist, Dr. Imani Khalid, described it this way: "It's not trying to speak to us, it's trying to see how we respond. The message is the reaction." This wasn't transmission, this was interaction, and that changed everything. Because if 3i Atlas was measuring us, not just biologically or technologically, but behaviourally, then the convergence wasn't an endpoint. It was a filter, a kind of test, a layer between input and output designed to observe how a planetary system organises itself under pressure. That was when the idea of the translation layer emerged. It wasn't made of metal or software or glyphs etched into stone. It was built on feedback loops, on real-time environmental shifts, and most chilling of all, on georesonant mimicry, the phenomenon where planetary-scale systems begin to reflect the harmonic patterns of whatever is stimulating them. In other words, Earth was beginning to mirror the rhythm of 3i Atlas, and the pattern Earth was echoing